So my name's Eleanor Saitta. I've been doing this stuff for a little while. Lately, I've been doing a lot more strategy work and kind of slowly moving up the supply chain and getting further and further from actually writing code, which is actually kind of fun because it turns out the human problems are a lot harder. All you folks with your heads down in assembly, that's the easy end. That's the really easy end. So I want to talk a little bit about some of the stuff that I've started seeing with some of my strategy clients and kind of, hopefully give some folks here some things that they can take back to elsewhere. So who am I talking to for this? Folks who are dealing with small to medium engineering teams. So somewhere between about 25 people where you can start calling it actually an engineering team as opposed to like two guys and a typewriter. And probably not more than 500 once you start getting above the 500 mark. Some of this stuff still applies, some of this stuff gets easier, some of this stuff changes, but this is kind of the sweet spot where I've been spending a lot of time and where I think that where this advice is targeted. So this advice is primarily for execs, legal counsel, and engineering leaders, also senior security staff who are looking up and looking to push larger changes inside an organization. If you have suddenly come in as a CTO somewhere and you've realized that, oh my God, there is no security here, there is nothing, or have come in as the first security hire for a startup that's been around 5 years, and you're like, wait, what do you mean you haven't done anything? This is you. Also consultants who are kind of coming in that same place. So I like to include a definition of what I think security is in most talks that I give, because my definition is a little bit different than a lot of people's. Security is a set of activities that reduce the likelihood of some set of adversaries successfully frustrating the goals of a set of users. This does not involve computers at any point, you will notice. And that's important because security isn't actually about computers. We made a terrible mistake owing to the fact that we called it computer security, where we thought that it was about computers. It turns out it's not. It's about what people are trying to get done in the world. So strategy, again, just to set a bit of a time frame especially, strategy is both kind of the worldview and the goals, but also the plan for accomplishing them in roughly a 1 to 10 year time frame. If your strategy is going to take longer than 10 years to complete, you're probably a nation state. If your strategy is going to take less than a year to complete, that's tactics, that's not strategy, you're not thinking big enough. So there's going to be a few sections to this talk. I'm going to talk a bit about governance level issues, a bit about engineering practice, and then a bit about kind of opinionated platform advice and basically the things that I think you can start doing and making strategic technical decisions that will make your life suck less. So let's start talking about governance. How many people here have done like risk evaluation work of some kind? Right. Risk is bullshit. Do you know your adversaries personally? Oh yeah, that's Joe. I've got a pretty good idea of like where Joe is today and like how he's feeling. Okay, you might be able to understand risk. Do you have enough adversaries that you have meaningful statistical data about them and you can construct abstracted analysis on collective behavior? If so, you are probably not a 500 engineer company. If you are a 500 engineer company and you have that much information about your adversaries, you are probably not a company that is starting out and just trying to get a picture for where it should go as far as security strategy. Or you just have a lot of adversaries and a lot of information for some weird reason, in which case I'm really curious, so come talk to me. Now, you don't need risk. Risk data implies exposure times probability. Probability means, hey, what kind of mood is Joe in? Is he likely to attack me today? You don't know. It doesn't matter. Exposure is enough for all of the decisions that you need to make. So you can talk about direct cost of an occurrence, cost to recover, opportunity and brand cost for an incident. You can talk about cost to mitigate. You can talk about operating profit, both direct and structural, from the operations that might be vulnerable. And you can talk about the attacker cost and the attacker return on investment. Right? This gives you a set of ratios which are sufficient for all of your decision-making process without ever having to make up a number that says, oh yeah, I believe that the probability of XSS is 17.9%. So one of the first things you want to start understanding as a company that's starting to think about strategy is, who are your adversaries? Now, I've just said you probably don't know, but you've got some idea. If you are a journalism organization in the habit of pissing off Russian billionaires, you have a pretty good idea of who your adversaries are, or at least some of the interesting and notable ones. If you run a bank, you probably know who your adversaries are. There are a bunch of annoying people who try to run card transactions through you, and, possibly some other folks. What do they want? Understanding where your adversaries' actual, goals are and what their profit model and that kind of thing is incredibly useful. I have forgotten the gentleman's name, but someone from DIN gave a talk at O'Reilly Security New York last year, and he was trying to understand, okay, so these people who steal service from us, what are they doing? What are they actually trying to get? And he went and traced through the entire profit cycle of fishers and carters and launderers and the return on investment structure and all of these things, and figured out, this is the ecosystem, and this is each player's profit model, and this is their margin. So if we can make stealing our services half again as expensive, they have no margin left. They get out of the business, or they move somewhere else. So obviously you want at least some understanding of what kind of capabilities they have. This is well, I don't actually quite like the, if Mossad decides to Mossad you, you're going to get Mossaded, because I do work with people who have nation-state adversaries, sometimes including Israel, and it's not that simple. There are risks that you can choose to take, there are games that you can choose to play, and there are levels of interest from adversaries and what capabilities they're willing to burn. But if you're looking at your kind of more conventional adversaries, are you talking about, again, this was someone else's typology from KiwiCon, and I can't remember whose, maybe Bilby's. Technically incompetent, disorganized adversaries, so random script kiddies, whatever. Technically competent, disorganized adversaries. This is a security engineer who's annoyed at you and kind of knows what they're doing, but isn't going to be super rigorous about it. Technically competent, well-organized adversaries. This is larger organized crime organizations and smaller national intelligence organizations. Technically competent, organized adversaries who are willing to kill for root. Obviously, that's a smaller set. So yeah, cost structure, return. One of the other things, often you get to choose which adversaries you fight. Sometimes you can say, well, okay, we recognize that there is national security interest in our data set, and we recognize that we are making a decision that it is not within our business model to attempt to do anything about that. So if they own us, hopefully they will be polite and not break all of our stuff. They probably will be, because they don't want people to know that they're in there. And we're just going to accept that. And that's a totally reasonable business decision, as uncomfortable as it makes some of us from a, I want to fight all of the people standpoint. So now you need to think about security outcomes and what you're actually trying to make happen. And one of the things specifically that you need to talk about is whose outcomes. We often talk about corporate security as in the security of the corporation and its services. It is less common that we talk about the security of the end users who are using our products. That's not universal. There are definitely some companies that are much better at thinking about that than others. I would argue that getting your users owned is very bad for business. You shouldn't do that because it makes them less likely to continue being your users, and especially to continue giving you money. And it's also unethical if that's a thing that motivates you in any way. So this means you need to understand what your customers, what your users are actually trying to do in the world. Not what they're trying to do in your system, but what they're trying to do in the world. And what their cost structure and their needs are, and how your system can actually make it more likely that they're going to succeed at their goals given their adversaries. You need both qualitative and quantitative data here. One of the things that my constant frustrations with metrics-centric engineering organizations, I'm really glad that you guys are using hard data. Could you think about qualitative data? It is just as useful, and in fact, sometimes much more useful, because you can get qualitative data when you don't have statistically significant numbers. You also need to plan with them. You can't simply impose structures on them. We'll talk about that a little bit more later. So incentive alignment. If you are the CTO of Equifax, you don't actually particularly, like you need to pay lip service, especially in public, to caring about the security of the system. But your incentive structure is to continue cutting IT costs so that you continue getting $90 million a year bonuses. And it doesn't really matter what happens to the company, because if something happens, you're not giving those bonuses back. You're already out the door. If you are working in a structure where the larger incentive structure is like that, you are not going to be able to meaningfully change security structures. If you are trying to do data protection work at a company that is in the business of holding all the possible data from users, you're going to find that very difficult to do anything other than kind of the minimum that the law requires. It's fine for a company to have an incentive structure that it's willing to acknowledge that doesn't necessarily completely line up with its users. It is a very bad sign if your company is not willing to be honest about the incentive structure that it's operating in. That is where you start seeing professional negligence lawsuits. If you're in the position of doing security strategy there, I highly recommend that you quit. So one of the other things to be aware of is that security is not, again, about computers. Physical security isn't a separate discipline. If you care about preventing access to your network, say in your office, you care about what the locks look like as well as what the network ports look like. The emotional well-being of your staff has a direct impact on their ability to follow procedure and perform securely. If you have a bunch of people who are really annoyed at your company, they are probably going to be a lot more vulnerable to phishing attacks because they don't care. Oh yeah, I'm going to go click on some stuff's going to happen, whatever. Oh, whoops, my machine's acting weird. Well, I'm just going to ignore that because, I don't want to deal with IT, they're annoying. If you are, and this is particularly if you are working in media organizations, NGOs, or any other kind of company that works in conflict regions, how many of your staff have PTSD or secondary trauma syndrome? They are not going to be in a good place for acting in a cooperative context or following procedure. It is your responsibility, if you're an employer who put those people in harm's way, to take care of them, and that impacts the overall security structure of your organization. And then there's what is your actual business model? Your company's operations have a financial security footprint, universally. If you're a merchant, you have market fraud. If you are a media company, you have libel and source protection issues. You probably have some kind of community safety concerns if there's a community that uses your systems. You definitely have operational security concerns that are separate from purely technical security concerns. One of the things to agree with at the exec level across the company is what is your exposure tolerance? Different companies make different calls on what risk they're willing to bear, on how much they want to gamble. Are you in fact feeling lucky? It is useful to understand exposure tolerance across different parts of the company, because chances are that they don't line up entirely. Again, if you are asked to cheat and pretend that one part of the company has a much lower risk tolerance than the risks it's actually taking, that's not a good sign. So maturity level. A lot of this stuff is most relevant at companies where you're just starting out in security, where you've been around for a while, you've been writing code for a while, or you've just got a pile of money as a new startup, and you realize that you don't have any of the routines or processes or policies or instincts in place yet. You're not going to be able to start out going 100 miles an hour. So know how fast you can move. Qualitative data is way more useful than quantitative data for all what the CMU security maturity model, they're lovely. You probably don't actually need that. So tech debt relates to this fairly closely. The longer you've been building things, the longer it's going to take to rethink them. A 2-year startup and a 10-year startup are very different places. The faster you've been working, the more debt there is likely to be per unit of complexity. So for a given size code base, if you've been churning really, really quickly and you're in a development velocity-centric company, you are going to have more stuff hiding in there. If you are working for a government contractor with super long timeframes, you're probably going to have documentation. Congratulations. But it's also going to be very slow to actually change anything. Has anyone here read the Stella report that came out recently from the Software Operations Resilience Consortium? It's a group of folks centered around Etsy, among other places where I used to work, looking at kind of human error analysis in security or in systems operations, not specifically in security. They came up with the idea of dark debt. So dark debt is technical debt that you do not realize is going to be debt at the time in which you are building it out. Most security debt is dark. This is useful because it makes it it is important to understand that because it means that you do not necessarily understand, even if you have a picture of the technical debt in the company otherwise, where the security debt actually is. How many people here know Brooks' Law? There's a shorthand explanation of it, which is basically that 9 women cannot make a baby in 1 month. If you have a project which is already late, adding more staff to it will make it later. If you have a project which is halfway done and running on time, and you add a bunch of security requirements to it and more staff to complete those security requirements, it's not going to be pretty. This stuff has to be planned in ahead of time. Ramp time is very real. Communication overhead is combinatorial. And it is very rare that you have fully divisible tasks unless you've properly structured your infrastructure to build in layers, and we'll talk about that a bit more in a minute. Brooks' Law is probably the single most important thing to understand if you want to try doing any kind of engineering transformation work. So we have to talk about compliance. Unfortunately, there is a long list of rules, including our new best friend, GDPR. All of these things are great for providing incentive structures for getting work done. They are rarely going to guide you in the direction of good security outcomes. That said, by all means, grab the incentives and run, because they will move companies in ways that absolutely nothing else does, and you can often actually make engineering changes that no one is going to let you do otherwise. Compliance rulemaking is probably second only to a breach for motivating people to actually, get their house in order. One of the structures which I think is worth thinking about is looking at what is the security plan that you would like to roll out, what is the architecture that you would like to roll out, and then talking to your lawyers and figuring out how to make it fit the compliance structure. That often works better than the other way around, but I am not a lawyer and I'm definitely not your lawyer. Formal governance, they're great for large companies. They're incredibly important for large companies. When you have time to roll things like this out, they're kind of maybe interesting. Processes and documentation are awesome. They're super expensive. You probably don't want to start here. If you are starting with ISO 27001 at the beginning of your security effort, it is probably being led by, acquisitions. Like, you want to make yourself an acquisition target, and so you need to look like you're secure. None of this is going to actually make you secure. So metrics are useful in theory. Metrics of things which are not real are not very useful. Your risk register is not a real thing. Metrics create incentives that shape your organization. Consider the metrics that you actually want, because you will not be able to get away from the damage that they do. Be careful with human metrics. They're great for killing staff morale. Attack volume metrics tend to be super low value for most small organizations. Look for metrics that will help you falsify hypotheses that your strategy is built around. We'll talk a bit about engineering practice. So, who here has heard of blameless engineering? Is that a phrase? 3, okay. So basically, if you want to make things better, you need to know what happened. If you fire people when they fuck up, they will never tell you what happened. So Having a policy that says, hey, if you fuck up, no matter how badly, we will fire you if you don't tell us what happened. But as long as you're like, hey, it's cool, there's a process, I'm going to go be a cooperative part of the process, you're fine. You are in so much of a better position for understanding the actual state and how work is actually done in your organization. If you do not have some level of this, you will never see a breach coming. You are not going to hear about what's going wrong. Assume that everyone who works with you is smart and shows up at work to do a good job. If you think that's not true, this is an incident response matter or a long-term talent management matter, not an issue for engineering practice. So another thing is looking at designing for human error. We are all human. We all fail. Your staff click on things for a living. Getting them to not click on things is not going to work. Do not try to train the fail out. Training people to not click on phishing attachments is basically useless. Instead, maybe try to make clicking on things actually safe. Right? If your IT infrastructure cannot handle the fact that a user clicks on the wrong thing, your IT infrastructure is compromised. If you can't do this, consider goat farming. The goats still fuck up and are terrible, but it's a lot funnier. Teach systems literacy. Don't try to teach process. Don't try to drill process. Teach people how to actually reason about the systems they're using. They will still make mistakes, but they will make smarter and more interesting mistakes. And security awareness training is basically someone screaming constant vigilance at you every morning. It's not very much fun. It's not particularly useful. How do you distribute responsibility for security in an organization? So you need to actually make it everyone's responsibility, not the lip service version of that where you put it on posters, but the serious version of that where you put it in their annual review and their project plans and their budgets. Every team should be directly responsible for the security of the services they build and operate. You need a single accountable person or team to coordinate between all the different teams because combinatorial vulnerabilities happen all the time, and also to deal with systemic issues, to deal with building out security specific infrastructure, etc. Good CSOs are hard to find. You probably can't afford one if you're a small company. Consider putting together a security council from a bunch of different orgs inside the company. Maybe get a consultant to come in and talk to that team or advise on a periodic basis. Do not put execs in tight decision loops for security because they will drop the ball. They don't have time. If you are standing up an actual security team as its own organization, do not be a gatekeeper. If your security team says no all the time, you will never hear about the cause of your next breach. It destroys collaboration. It makes people scared. That makes them hide things. You're back to the don't punish people thing. Make friends, bribe people, give them candy, give them whatever they need. Literally task everyone on your security team to go make friends with 3 or 4 engineers on different teams. Understand what the teams need. When you need to say no to something, explain the risk structure to that team, get them to be the ones to say no. You still have the stick that you can beat people with that says no on it, but it's expensive. So engineering principles are very useful to guide larger tech orgs that are building out complicated systems. Teaching them is difficult. I think it's really worthwhile. I think that the way to deal with the kind of low-level bugs that we normally put in secure coding training is to fix them at the library level, and then teach people how to think again. Capability in your engineering infrastructure is a liability. Every server that you have running is a server that can attack you. Every server that isn't running is a server that can't attack you. All of the excess capacity that you have in your database system is great for fast data exfiltration. All of the excess complexity that you have in your wire formats is great for finding vulns in. This is an interesting one. Traditional engineering work is structured around making failure rare, like time before failure. DevOps-style modern engineering work is much more structured around making recovery fast. Those lead to 2 very different systems architectures. Security says everything fails, so you want to be able to limit the scope of failure. That is a third very different systems architecture. The systems that you are operating are probably designed by a mix of these mindsets, and you need to understand which mindset is operating where and how they're getting in the way of each other. And you need to understand which team is operating from which mindset and when. If you build products, your design team needs to be part of the security loop. Design determines the security outcomes that your users can achieve. Engineering determines whether or not they can actually get there. You can hire 4 product security designers as a separate discipline if you are big enough. If not, there are people who will consult on it. QA matters. If you don't have a QA team, you can't do security work. If you don't have tests, you don't understand what's a bug. It is shocking to me that there are, in fact, still large software companies that just don't really do testing. But, turns out. Hiring versus consulting. If you're a small company, you cannot hire all the talent you want. You also cannot afford it, even if you could hire it. If you can't afford it, write me a check. You want outside perspectives from time to time, but you need some in-house staff. You need internal folks at an absolute minimum to be driving the application environment security, looking at your library footprint, looking at third-party code that's coming in, defining security monitoring rules, and doing at least second-level triage, even if the kind of SRE or ops teams are doing first-level, backstopping architecture decisions, defining requirements for security-specific infrastructure, and evaluating and managing consultants when you do bring them in, because they do not self-manage. Build versus buy. If you are an engineering-centric organization or kind of an enterprise-centric organization, you have very different kind of opportunity surfaces. Buying security, apologies to all the people here who sell security solutions. Buying security solutions is mostly a good way to waste a lot of money on snake oil. If you have a competent dev team, you can roll out a lot of stuff a lot more cheaply, but then you pay the infrastructure integration cost. It is surprising to me, but many organizations will buy systems that they do not understand the purpose of. Don't do that. Many of the systems that you can buy that are just kind of slapped in front of something else are probabilistic mitigations at best. They are always going to fail eventually. Understand that. Threat intelligence. Threat intelligence is a lot of fun because you get to feel like a spy and you get to understand what all the people are doing. It's also expensive and irrelevant for small companies, I'm going to argue. If you do not yet have proper segmentation between services and hosts, you are wasting your time doing threat intel work because you don't have basic protections and the understanding of what it means to be, the ability to determine whether or not you're owned. Peer sharing is great. Indicators of compromise are great. Yes, get stuff into your log monitoring streams, that kind of thing, but this is not where you start spending money and time. So I'm going to run through these somewhat quickly. Platform choices for a more boring life. Ideally, you want to engineer systems that are boring. Increasingly, companies in this size range are starting to build like small little platformlets. There are a lot of ways you can go about doing that. Some of them are terrible. Some of them are more useful. Kill bug classes. If you are doing security engineering work and it is not directed at killing a bug class, it should be categorized as emergency response work. Anything else, you're not actually solving the problem. You're maybe solving one instance of the problem, unless you're killing traversal. And that's the one exception. Again, if you're rolling out mitigations that are probabilistic, they will fail eventually. Save your time, save your money, save your CPU cycles. Separation of concerns. If you can shard your system into multiple layers that can actually provide meaningful property enforcement against each other, you are in a much better position. You're in a much better position even if all they do is reduce the complexity that your engineers have to think about at a given point in time, because engineers are human and combinatorial complexity is very hard. If you, for instance, have a nice separate library layer and you can make strong guarantees about, hey, functions that we haven't chosen to expose out of our application environment to application developers are not easily callable. Fine, you've got the library in there that's great for performance SQL, and it's got vulnerable query functions in there, but you've got a shim in front of it that makes sure they're not callable. You now have one less thing to do, and your engineers don't have to wade through the documentation of how not to write a SQL injection every time they're reading a spec. Because if you've got bugs that you cannot mitigate against except by developer action in each instance, and you haven't killed the bug class, you need to actually document them and remind people about it, and that's time-consuming. So layers, even if they are not strong security guarantees, layers that let you reduce complexity can be very useful at managing the intellectual effort. Programmatic infrastructure, for the love of God, do not have humans configuring switches or where workloads live on individual servers. Definitely do not have them repeating the same information into multiple different systems in multiple formats, at different points in a deploy process, because they will make mistakes. And many of those mistakes will have security implications. Keep all of your state in one place. Ensure that you can move cleanly between configurations under basically any circumstances. Orchestrate deployment. The same way you push code, push config changes in the same way. If you do this right, it lets you be much more aggressive about segmentation and response, because it means that you actually have computational understanding of what goes where. It lets you automate cross-checks for rule enforcement. It lets you run ops in two-person rule mode, where you can understand that oh yeah, we've got a proper trail on when switch config changes were checked in and reviewed before they were deployed. And it also lets you do faster disaster recovery. You don't have to worry about, oh, right, we've got all of this stuff which has changed in the router, and how is this thing configured? Oh, whoops, that config file is a smoking hole in the ground now. So segmentation. Segmentation is not just firewalls. So horizontally between systems and instances, sure. Vertically within a system, and also temporally across execution lifetimes, it's all the same thing, right? If you've got proper service discovery, you can have granular firewalling. You can have per-instance credentials. Inside a host, you can have process namespaces. You can have syscall ACLs, enforced by AppArmor or whatever. You can fast roll VMs. Last time I was talking to Dan Kaminsky, who was working on VM with, I think was it 2 milliseconds startup time? The goal being that you've got, maybe you let that VM serve 50 web requests, then you blow it away. Who cares if it gets compromised? It's got a lifespan of 50, 100 milliseconds, and good luck persisting. Maybe, if you know what you're doing and you know that's the environment you're coming into, sure, but your attack had better be fast. Don't patch. Patching deployed systems leads to drift. Treat disk images as immutable. Redeploy every time you need to make host changes. If redeploying is too slow, fix that. There's no reason why it should be that slow anymore. This means you get really good at rebooting all of your services, which is a great thing to be able to do. If you can, run all of your prod hosts with all the system disks read-only. There's no reason for those disks to be changing when they're serving functional load, so don't let them. Don't give your attackers capability you don't need. Observability. Most people don't have the instrumentation to understand whether or not they've been compromised, which is why most people get told by other people that you were compromised. Events, not log lines. Log lines are useless. They don't have enough context with them. Correlation is great. Make your assumptions visible, because your correlation will be wrong some amount of the time. Log syscalls directly. Go Audit is a neat tool from the Slack team. Instead of using OS query that's not on all the time, or that's it's designed for periodic attachment, or running the rules locally on the box and letting an attacker who's on the machine know what the rules and what you're interested in, just log everything. If you have a small security team, security rates the alerts and SRE triages them. You probably don't have the scale for doing machine learning on your logs. There are lots of people who really want to sell you that. They're mostly blowing smoke still. And even if you think you do, or you're using one of the products that's like aggregating logs from all of these people and thus shipping all of your logs to yet another party, now your alerting system is gameable. Now your alerting system is actively in play. That may not be what you want. I'm going to skip ahead a bit. Limits are great, auto-scaling, blah, blah, blah. Make systems that humans use which have predictable load slow when they get too much load, because the humans will complain. It's a great alerting system. Trust is hard. Know what you're trusting. Know the service dependency graph in your systems. Know which third-party services are root equivalent for you. You know, if PagerDuty goes down, are you screwed? Probably. Third-party library auto pulls and deployment are terrible. Don't do that. You should know this by now, but you know. Actively manage trust chaining if you can in your code deployment process. Signed commits, binary transparency. TPM attestation is still a bit of a stretch for companies in this size range, but if anybody's feeling adventurous, it's really cool. You know, you want to be able to say not just that something was trusted on a given host, but that something was trusted on the host before it. Do not automate. Orchestrate. If you automate, you give your adversary shiny new tools. In other words, the reactions that your systems have when things happen. You don't want to give them capabilities. Keep a human in the loop, because that human is going to, A, catch the system when the automation screws up, and B, hopefully not respond to adversary activity. Anything which has security implications needs to be orchestrated, though, because it needs to be done the right way each time, repeatably, reliably at 3 in the morning. I'm going to talk really briefly about IT and kind of the other half of our systems that we forget about. Just like servers, you need observability. Observability on laptops is socially complicated because your employees get really freaked out when they realize that you're reading all their web browser logs. This needs policy cover legally, especially starting next May, but also it needs to be introduced carefully. You need to be very clear about the conditions under which you're looking at stuff, what's automated, what's not automated, that kind of thing. You also need proper observability in all your third-party services. Who here uses G Suite? Very few people. I'm impressed. The Google Apps hosted stuff. I see a lot of companies using them. I see very few companies that understand what third-party applications are integrated against those tools. And being able to say, like, who actually can read all of your Google Drive is surprisingly rare. Social reinforcement for access monitoring. You know, if you've got a set of teams that need like direct access to end-user data, something like that, make sure that you, A, have audit trails, and B, email their manager, you know, once a month with an audit report, just so that, not because you want them to be paranoid, just so that everyone knows that, like, hey, this is tracked. Segmentation, same thing. Beyond Corp is really cool. You're not Google. Build stuff like it's internet-facing, and then don't put it on the bloody internet because you're going to screw up somewhere. Users have different risk levels. Do not treat all users the same. Do not treat all users' machines the same. Differential hardening makes it a lot easier to get people to accept the fact that, yeah, some people don't have local admin on their machines. Compensate those folks with better IT service so they can still get their job done. Harden your office infrastructure. Please harden your office infrastructure. Don't let people just walk in. If you have good lawyers, your lawyers are the best friends in the whole world. Make friends with your lawyers. When your lawyer says, hey, that's really dumb, listen to them. This is not something that I would expect to have to tell people. It turns out you do. Legal discovery is really, really terrifying. Data retention limits are a really excellent idea. Who uses Slack here? Slack does not delete data, even if you have a data retention limit set, unless you pay for enterprise mode. Even if you do pay for enterprise mode, Slack will not tell you the time frame in which they delete that data. When you are dealing with third-party services, legal needs to be involved in negotiating every contract. You need a legal team that actually understands IT security, and you need to push back on stuff like this. if you are dealing with US service providers, they will hand over all of your data to the government on an administrative subpoena. You need to get notification commitments from them in writing in your contract. There's some other interesting games you can play with third-party counsel there and stuff. Jump through this a little bit. You can't build good tech without mature governance. Governance alone will not save you. Any process that you can automate, do automate it, but be aware of the workload you're adding to people's jobs as you build this stuff out. Most staff in your organization will only see the technical side of a security effort. If you are trying to pitch a security transformation effort, there needs to be an obvious technical component at the beginning, even if you know what you mostly need to start with is governance. Culture change. Culture change is hard and slow. People are very good at detecting bullshit around culture change efforts. That's probably the single biggest piece of advice. Like, take all of that seriously and don't try to cheat on that stuff. These are the 3 most important security books you can buy right now. They're the ones that I'm recommending to everyone. I can give you names again after, so I know we're running low on time. Sidney Dekker is coming out of the aviation security world. He is going to teach you why phishing training doesn't work. Kathy Sierra is going to teach you how to do product design so that you don't hurt your users. And Nancy Levison is going to teach you how to do actual systems reliability engineering with a capital E. Thank you very much.
Thanks, Ella. A lot of stuff there. Anybody got questions? No question? Oh, there's a question.
Can you get back to the responsibility slide?
Probably. Oops. Yeah.
Okay. Do you realize that this is the core tenet of ISO 27001?
Yeah, I mean, I'm not saying that 27001 is a bad idea. I'm just saying that starting with the framework as written and aiming for framework compliance versus aiming for impact is often the wrong choice for smaller organizations.
How you define smaller?
Between 25 and 500 engineers. Okay. And especially smaller organizations that are just getting started and taking security seriously. If you are leading with a heavyweight governance effort before you have host segmentation, no. Put out the actual fires first, then put in place governance structures that are going to drive long-term stability for the firefighting efforts.
If you got to 500 engineers without any security structure in the organization, you are not going to make it without top-down governance.
I don't necessarily agree. That is not what I've seen. I think that there are plenty of ways to do top-down governance that do not involve standards compliance. Governance, yes. Compliance, no. These are 2 completely disjoint things.
I'm talking about governance, not compliance.
Yeah, of course. But I mean, you can't do, like, any organization where you have people trying to collaborate, you have something which is functionally governance because you have an organization. You have a management structure. You have some kind of process and policy, even if it's really loose.
I've seen organizations that didn't have any process. You need to put the foot down first, then you can take out the fires.
That has not been the ordering that I would normally use.
Okay, thank you.
Okay, any more questions? Okay, thanks, Ella.